Welcome viewers. In this video we'll see the Poynting vector followed by the Poynting theorem derivation. First we'll see the what is meant by intrinsic impedance or characteristics impedance. This given as a intrinsic impedance or characteristic impedance. It is a ratio of electric field to the magnetic field, E divided by H. The ratio of electric field by magnetic field is termed as a intrinsic impedance or characteristics impedance, and also it is a ratio of square root of permeability to permittivity of the medium, square root of mu by epsilon, right? The another term is square root of mu by epsilon, also it is given. The unit is ohms. Then we'll see the Slipian vector. So it is a vector which is defined at every point such that its flux crossing out any volume is 0. It is termed as S. So del dot S equal to 0, right? It is defined as a every point such that its flux crossing out of any volume is 0. So del dot S equal to 0. So S can be given as del cross V into H. What is V? V is the electric potential, H is magnetic field intensity, right? So now we discuss the intrinsic impedance or characteristics impedance followed by Slipian vector. Now we'll go to the Poynting vector. What is Poynting vector? It is defined as a cross product of vectors E and H. S equal to E vector cross H vector. S vector equal to E vector cross H vector. What is A vector cross B vector? AB sin theta. So that E vector cross H vector equal to E dot H dot sin 90, because the angle between E and H is 90 degree. So sin 90 is 1. So that S equal to E into H, right? The Poynting vector S equal to electric field multiplied by magnetic field. Now we are going to substitute E equal to V by L. Electric field intensity is nothing but potential by length. Similarly, H equal to I divided by 2 pi R based on the Ampere's law. So this is a general formula. E equal to V by L, H equal to I by 2 pi R. Now we will substitute these two. E is replaced as V by L, H is replaced as I by 2 pi R. So while multiplying V into I divided by 2 pi RL. V into I divided by 2 pi RL. This V into I is nothing but power, voltage into current. 2 pi RL is nothing but a area, right? So power divided by area. So the Poynting vector gives power divided by area. That is, Poynting vector gives power per unit area. So the Poynting vector will give the term power per unit area. Now we'll go to the Poynting theorem. So the Poynting theorem, first we'll start with Poynting vector. Poynting vector is defined as cross product of vector E and H. So S vector equal to E vector cross H vector. Poynting theorem, we start with the Poynting vector. So Poynting vector is nothing but cross product of electric field intensity and magnetic field intensity. Take divergence on both the side. We are going to take the divergence on both the side. So divergence of S vector equal to divergence of E vector cross H vector, right? The divergence is taken on both the side. But in general, divergence of U cross V, we can take two terms, two general terms. U cross V means, how will you write? Divergence of U cross V equal to V curl of U minus U curl of V, right? First we need to write this V, then curl of U. Then you have to write V, then curl of V. So this is a general formula. So based on this general formula, we can write divergence of E vector cross H vector can be written as H curl of E minus E curl of H. By referring this general equation, general formula, we can write the divergence of E vector cross H vector can be written as H curl of E minus E curl of H, right? So that we can write this. So divergence of S equal to H minus dou b by dou t. The curl E is nothing but minus dou b by dou t. Minus E, the curl H is nothing but J plus dou d by dou t. Right? So divergence of S, this divergence of S, this term is replaced by this formula. In this, curl H is minus dou b by dou t. This curl E is minus dou b by dou t. Curl H is J plus dou d by dou t. Now we'll substitute one more, B equal to mu H. We can replace this B with mu H. Similarly, D is epsilon E. There is a relation available. Displacement density D equal to epsilon into E. So that this divergence of S equal to H into minus dou B by dou T. This B is replaced with mu H. Similarly, minus E of J plus dou by dou T of this D is replaced with epsilon E. Right? Now we can simplify this. Divergence of S equal to minus mu H. Right? Already one H is there, one mu is taken outside. So minus mu H dou H by dou T. We can multiply inside E into J, minus E into J, and multiply this with the term minus epsilon E dou E by dou T. This epsilon is taken outside. Right? Now we got three terms, minus mu H dou H by dou T, minus epsilon J, minus epsilon E dou E by dou T. Now we'll go for the further simplification. For example, dou by dou T of half H square. How will you write the dou by dou T of half H square? That is, we are going to differentiate with respect to H. So 1 by 2, the differentiation of H square is 2H dou H by dou T. Right? So dou by dou T of 1 by 2 H square is nothing but 1 by 2 into the differentiation of H square is 2H dou H by dou T. These 2 got cancelled. H dou H by dou T. Right? So dou by dou T of half H square is equal to H dou H by dou T. See this term available, H dou H by dou T. This term can be replaced by this term, dou by dou T of half H square. We are going in a reverse order. This term we are going to replace with this. Similarly, dou by dou T of half E square. Dou by dou T of half E square equal to 1 by 2. The differentiation of E square is 2E dou E by dou T. So the 2 got cancelled, E dou E by dou T. So this value E dou E by dou T can be replaced with dou by dou T of 1 by 2 E square. Right? So this value, this expression, this value and this value, we are going to replace with this term. So that divergence of S vector equal to minus mu. This H dH by dt is nothing but now dou by dou T of half H square. This value is replaced with this value, minus EJ epsilon E dou E by dou T. E dou E by dou T is replaced by dou by dou T of half E square. Now it is replaced. Now we'll go for the further simplification. Divergence of S equal to minus dou by dou T. This mu is brought inside. 1 by 2 mu H square minus EJ. This epsilon is brought inside. Dou by dou T of half epsilon E square. Right? So this dou by dou T available in both the term that taken as common. Minus dou by dou T of half mu H square plus half epsilon E square minus EJ. So these two terms, this minus dou by dou T is taken outside. Right? Now we'll go for the further simplification. So by rewriting, we got minus EJ equal to dou by dou T of half mu H square plus half epsilon E square plus divergence of S vector. Right? So this term is brought that side so that it become positive. We'll take this is the term 1. Minus EJ will take it as term 1. This dou by dou T of half mu H square plus half epsilon E square will take it as second term. This divergence of S is the third term. So we'll analyze these three terms one by one. Right? So this is the first term, this is the second term, this is the third term. What is the first term Ej? Ej is nothing but this electric field intensity and current density. So the electric field intensity is V by L. Current density is I by A. Right? E is nothing but electric field intensity V by L. J is the current density I by A. So that Vi divided by A into L. Voltage into current is nothing but power loss. Power or power loss. Area into length is nothing but volume. So this power loss can be written as energy loss divided by second. So energy is nothing but power into time. So energy divided by second will give the power divided by volume. So the Ej is nothing but energy loss per second per unit volume. It will give the value of what is the energy loss per second per volume. If it is plus Ej means energy loss per second per unit volume. Minus Ej means energy generated per second per unit volume. Right? This plus minus represent either energy loss or energy generated. Right. Then we'll go to the term 2, second term and third term. The second term is nothing but energy stored in electromagnetic field per unit volume second. Per unit volume and second. So the term 2 was giving energy stored in a electromagnetic field. The term 3 gives energy outflow per unit volume and second. Right? This gives the energy stored. Term 3 gives the energy outflow. So by combining these three, the Poynting theorem, the statement of Poynting theorem is nothing but, according to Poynting theorem, energy generated per unit volume per second, that is the first term, is the sum of energy stored in magnetic field per unit per second and energy crossed per unit volume and second. Right? The term 1 equal to sum of term 2 and term 3. That is the statement given by the Poynting. Right? So the energy generated is equal to the sum of energy stored and energy outflow. So this is the statement given by the Poynting theorem. Now the Poynting, this equation we can write it in a integral form. We got the Poynting theorem, the term 1 and 2 already we discussed. We can convert that into integral form. So multiply with volume on either side of the above equation. By referring the above equation, we are going to multiply with volume. So volume of dou by dou t of half mu h square plus half epsilon e square plus divergence of S equal to volume of minus Ej. So volume multiplied on both the side. So it become volume integral. So integral V is nothing but triple integral. Dou by dou t of half mu h square plus half epsilon e square into dV. Is that volume integral? Similarly this term, integral V divergence of S into dV. Similarly this term, integral V volume integral minus E into J dot dV. So everything now converted into volume integral with respect to dV. So this is the integral form of the Poynting theorem. Right? So this got the integral form. Previous one is the normal form, differential form. This will be the integral form. So in this video we discuss about the intrinsic impedance or characteristic impedance, Slipian vector, Poynting vector, followed by Poynting theorem, the proof of the Poynting theorem. Finally we got the integral form of the Poynting theorem. Thank you.